It's not like I don't have any own projects, but because this issue interested me, I cobbled together some Arduino and a MOSFET and a display to output a 50% PWM from 4 Hz. You can see it on the multimeter, up to 32,000 Hertz output. There's no smoothing after the MOSFET, as you can see, and probably here. But I have some smoothing before input, and so there's a big cap bank and a resistor inline, so my power supply displays the current draw, so I can estimate if there's anything wonky going on inside the commutation of my fan here. So with this switch I can increase the frequency. So this is 8 Hz. You can see 8 Hz. You can hear it's fluctuating faster, and it's at about 50 milliamps. 16 Hz. (32 Hz). Still 50 milliamps. 64 Hz. And you start to hear the PWM at 128 Hz. Yeah, it becomes more audible. Current draw is still at 50 milliamps. This is 1 kilohertz. 2, 4. Current draw went down bit. 8 kilohertz. Now that's nasty sounding. 16 kilohertz. I can't hear that anymore. You might. Current draw is furtherly a bit down. And 32 kilohertz. And current draw is at 44 milliamps. Fan is working fine. Okay, I'm gonna do the same test to some other fans. Okay, so this is the hot end cooling fan of my Inno 3S1 Pro, and at 4 Hz it's working fine. 8. Current draw is at about 46 milliamps. Still 46 milliamps. Okay, doesn't like that. We can hear it spinning slower. Oh, no, it even stopped. Okay, so it doesn't like the high frequencies. This one. Okay. Okay, so here's my only other 24 volt fan. It's one of those 50-15 blower fans. It's at 4 Hz and drawing about, I don't know, 80 milliamps. So at 8 Hz, 16 Hz, 32, and we can barely even hear the PWM frequency anymore. 64. We start to hear something. Current draw is still at about 80. Now it becomes audible. This is too high. Yeah, and it stops. So those high frequencies, not for this fan. $32 though, not even bad, not half bad. Okay, so I'm testing some more fans. These are 12 volts. This one is a CPU cooling fan, and at 4 Hertz it doesn't even start up. I have to like push it. But if it's stopped, it still draws current. Let's see when it's gonna start spinning, at what speed. Can hear it trying to start up. There we are. At 32 kilohertz only. The other speeds only work if it's already spinning. But if it is, they all work, I think. Let's see it again. Oh, that's my multimeter. Oh, and in the meantime it stopped spinning because it didn't like the 32 kilohertz, 32 hertz. So this time it managed to start up at 16 kilohertz actually, but usually it doesn't. Okay, so we have a 120 millimeter fan by EBM Papst. At 4 hertz it draws about something between 120 and 115. Let's see how this goes. Current draw is at 120 now. Oh, it's very audible. Current draw went down a bit. Current draw is still at 100 milliamps, but it's slowing down considerably. Current draw is actually up at 137. Now it's barely spinning. We have 165 milliamps. So all of that current is being consumed inside the electronics and not actually in spinning the fan. You have 16 kilohertz, 180 milliamps current draw. It's barely spinning. So this fan would need some kind of smoothing cap for high frequencies to work out. So here we have an Arctic F12 PWM fan. It's the regular PWM version, not the PWM PST one, and it's an older model, I think. Yeah, it's drawing something between let's say 170 milliamps. And at 4 Hertz it's spinning fine. Let's get this into the picture. And 64 Hertz is really audible. You can hear it spinning up, and it's drawing quite some more current at these higher speeds. Four kilohertz, and milliamps are 228. For me, there's nothing audible anymore from the PWM. I can only hear the fan, and we are stabilizing at 230 milliamps. Now we are at 16 kilohertz. And it's working fine. And 32 kilohertz. Current draw went down a bit, actually. Okay, and here's another one of those random CPU cooling fans, just to see what different fans are doing. So we're drawing about 120 milliamps, and 4 Hertz is working out. Current draw is stable. Current draw is going down a bit. This is very audible. Current draw is going further down. We're still at about 100 milliamps. Now, fan spun up again. Now current draw is up again at about 115. 8 kilohertz, and it's drawing 140 milliamps, and it's spinning way more stably. 16 kilohertz, even more. Current draw spinning up further. And 32 kilohertz, and it's running fine, very smoothly, nothing to be heard. Okay, I remembered I had some other fans to test. So this is a 12 volt Nidec 120 millimeter fans. It's a rather thick one. And while it does run at 4 Hertz, it doesn't sound nice, and it draws at about 110 milliamps. Oh well, it sounds like a moped. 16 Hertz, we don't like. Still draw 55 milliamps though. 32 Hertz, no sir. 64. Let's see if it spins up again at some point. Nope. No. So this one only works either with a smooth PWM or with PWMs below 16 Hertz, because this is already too fast. Okay, and last but not least, we've got a rather powerful 12-volt blower fan that's supposed to draw 1.32 amps at 12 volts if it's going 100%. At this 50% PWM at 4 Hertz, it's drawing something about 400 milliamps. And let's see how it does with other PWM values. So 16 Hertz is fine, and it's stabilizing at 400 milliamps. 32 Hertz, 400 milliamps. 64, we can hear a low hum. Current draws down a bit. Current draws down a lot. It's at about 250 milliamps now, but it spins down as well. Current draw is up a bit actually, but the noise is really bad. 2000 Hertz. Current draw is up again and it's spinning faster. 4 kilohertz, spinning even faster. 8 kilohertz, even faster. I can't hear this frequency anymore. And we're at about 520 milliamps. And the final piece, 32 kilohertz. 540 milliamps, and it's running fine. PWM is inaudible.